Welcome Math 20-2 to your last lesson in measurement. So today we are doing linear scale factors versus surface area and volume. We're linking them together. So we've already done area, we've done perimeter, now we're looking at 3D shapes. So we have surface area and volume when we're looking at 3D shapes. So let's start off here. We have our original dimension of this shape here. I'm going to zoom in a bit so we can see this a bit better. There we go. Look at that, nice and big. So my original dimension here is 3 by 5 by 1, which gives me a surface area of 46. Okay? Now, then our new dimensions are like this, which my new surface area is 184. How do we get surface area? Well, we have to go 6 times 10 times 2 plus 6 times that times 2, and then that times 2. Okay? So it takes us a while to do that. Now, I'm going to just help you along here. So let's take a look at this one here. So my area for this one is going to be 6 times 9 times 2, then 9 times 12 times 2, then 6 times 12 times 2, which will end up giving me 468. Okay? Now, I want a linear scale factor of 1/6. So my dimensions all change. If we're looking at 1/6, I'm going to have 1.5 by 1 by 2. Okay? Now this would be 1.5 times 2, 1.5 times 2, which is 3 times 2 is 6. And then 1 times 2 is 2, times 2 is 4, so that's 10. And then we have 1.5 times 1 times 2 is 3, so that's going to give me 13. Okay? So my new overall is 13 over 468. Whoops, that's a 6. Okay? Both of these can be divided by 13, which will give me 1 all over 36. Okay? Let's take a look at the next one. So we have 4 times 5 times 2. 4 times, no, oh, sorry, before we do that, look at this, look at that, look at this, look at that. You might already find that. You might already think you have the secret behind linear scale factor and surface area scale factor. Not just area, just this little surface area scale factor. Okay? So let's take a look at this. 4 times 8 times 2, which is going to be 32 times 2, 64. Then we have to add 8 times 5, 40, 80, which will give me 144. No. So 80. And then we have 4 times 5, which is 40, or 20, 40, which will end up giving me a total of, 184. Okay? 4 plus 40, 184. Now, we take a look at this here. We want 3/2 of everything. Okay? So 12 divided by 2 is 6 by, and then we have 12 by 5. Whoa, that's going to be a 7.5. Okay? Now this one here, we do the same thing, and I'm going to end up getting 414. Okay? Notice how each of these is multiplied by that, but we're always only multiplying 2 at a time. So we're only multiplying 2 linear scale factors at a time when everything's being added. So we end up getting 414 all over 184. Okay? Which is the same as 9 over 4. Let's try the next one. 3 times 12 is 36, plus, then we have 12 times 6 is 72, which gives me 108. And then I have 3 times 6 is 36. Oh, just wait. It's 36. Oh, I've been forgetting to multiply by 2. So we go over that again. That's going to give me 252. Okay? That should just multiply that number then by 2. We have 2 of everything. Okay? Now, let's take a look at this here. We're going to end up getting, we want 2/3 of everything. So that times 2 divided by 2 is 4. So we have 24 divided by 3 is 8 times 8. And 6 times 2, 12 divided by 3 is 4 by 4. Okay? Now we multiply these together. 2 times 8 is 16, and then we have to add another 8, which is going to give me 24, and then I add that to 32, 24 and 32 is 56, times it by 2 is going to give me 112. Okay, now we have 112 divided by 252, and that's going to give me a total of 4 over 9. I actually don't even have to calculate that last one. I should know by now by looking at this. So looking at that, compare this to this. What do we notice? Okay? Now let's take a look at my next one. We're going to look now at volume. Volume is so much easier to calculate. All we have to do is we multiply these three together. Give us 15. This one's 120. We get 8. 8 to 2. That's interesting. Let's take a look at this one. We have 9 by 6 by 12. So that's going to give me 72 by 9, which will give me 648. Okay? We want 1/6 of everything. So it's the same dimensions as before. So we have 1.5 is above, multiplied by 1, multiplied by 2. And we have this right here. That's going to be 3 times 1 is, well, 3. Okay? Now, we have this divided by that. 3 divided by 6, 48. And that gives me 1 over 2/1/6. Okay? Let's take a look at the next one. 4 times 5 is 20, times 8 is going to give me 160. Okay? Now, we have the same dimensions as we had above, which was 6 by 12 by 7.5, same scale factor. And we're going to have here, multiply these together, I have 72 multiplied by 7.5 is 540. Okay? Now let's go this. We have 540 all divided by 160, which will end up giving me 27 all over 8. I have a secret, so I could do that one. I can't really divide that fast in my head. Just the trick is, maybe you guys can find the trick, the relation between this and this by now. Let's take a look at the next one. Okay, 3 times 6 is 18. Okay, 18 times 12 is going to give me 16. Or it's just, yeah, 6 to the power of 3. Okay, now the next one is going to be, we want everything, we have those up there, 2 times 8 times 4. Now we want to multiply all these together. That's 8 times 8, which is 64. So I take a look at this, I'm going to end up getting 8. Oops, sorry, I have to put this in. So we want 64 over 216, which gives me 8 all over 27. But that's 81, kind of looks like 81. So I want you to think about this here. We're having all three of these linear scales being multiplied together. So 2/3 multiplied by 2/3 multiplied by 2/3. Here we have 3 over 2 multiplied by 3 over 2 multiplied by 3 over 2. There's my scale factor. Here we have 1/6 multiplied by 1/6 multiplied by 1/6. Isn't this the same as? Doesn't that kind of look like that? This one is the same as, because we multiply all these by 2. Here, we're only multiplying 2 together at once in the area. In the volume, we multiply 3 together at once. And also, it's called cubed. So what do I do to my linear? That's to the 1. So here is, right here, I strongly suggest you take this section here and you highlight all of the important information on this page. Okay? So there's some very, very, very good important stuff here. So it tells us our ratios. Okay? It has linear scale factor, perimeter scale factor, area scale factor, and explains it to you. Okay? And then it has the ratio, how you compare it. Next one is surface area scale factor, which is actually the same as area scale factor. And then volume scale factor. And look at how they do that one. So I would definitely suggest looking over this and analyzing. Okay, let's take a look at here. Now we're going to look at class example number 1. We have Axis Global Limited produces globes with a diameter of 30 centimeters. Isabel, manager of Axis, has her employees construct a globe with a diameter of 1.5 meters to put on the roof of the building. Okay? Now, the surface area and volume of the calculations of the globes with a diameter of 30 centimeters are shown below. Complete the work below to calculate the surface area to the nearest 0.1 centimeter squared and the volume to the nearest 0.1 centimeters cubed of the globe with a diameter of 1.5. Okay? So, here we go. First they're finding our surface area of the globe. And it's that. Now, we're finding the surface area of the globe, that's 1.5. So I just go 4 multiplied by pi, multiplied by, my radius is 75, which is half a meter. Okay? Now I look at this, I'm going to end up getting a total of, if I plug that onto my calculator, 7,685.2. Okay? Oh, 0.8. Now, let's take a look at the next one. We're looking at volume. So, we have 4 over 3 pi, and we have 75 cubed. So I'm going to plug that onto my calculator. This one I don't have already plugged in, so I'm going to plug it in myself right now. So, there we have 4 divided by 3, okay, multiplied by second pi, then we have, and I'm going to push, 4 divided by 3, enter, multiply by second pi, enter. Then we want to multiply this by 75, and we're going to square it, which will give me this, 23,561. I think. Oh, it's not squared, it's cubed. Sorry. So I'm going to multiply by 75 one more time. I have to multiply by 75 one more time, which gives me that there. I just looked at my answer when I moved my calculator. I was like, wait, I squared it. Should have been cubed. This should be cubed, because that's cubed. So I get 1767145.868, and that is a total of centimeters cubed. This is centimeters squared. Now, use the results to determine to the nearest whole number the following scale factors for 30 centimeters. So we want the linear scale factor. So what is going to be the linear scale factor? Well, the linear scale factor is, well, 150, the radius, or the diameter, over the actual diameter of 30, which gives me 5 over 1, okay? Which is the same as 5 to 1, okay? 5 to 1. There so you can see it all. Sorry. The next one is surface area. Well, let's take a look at my surface area. Here's one surface area, here's the other surface area. So we want new divided by old. So I'm going to have 70685.8 centimeters squared all over 2827.4 centimeters squared. So I plug that into my calculator. That's going to end up, I'm not even going to do it because I know this, so this is going to give me a scale factor of, this one was 5, this one's going to be 25, a ratio of 25 to 1. Now my volume is going to be 1767145.868, and this is centimeters cubed, all over 14137.2 centimeters cubed. And I'll trust you guys to punch this in your calculator at home, but I'm just going to go 5 cubed, which is 125. And if I did punch that in, let's try this. I'm going to divide it by, because that one's already in my calculator, so divide this by 14137.2. Oh, and that's fairly close. I might have had one decimal wrong there, which gives me 125 approximately. Okay? That's close enough. We just round up. So, it says, show how to use the volume scale factor to determine the layer, the other one. Well, all I have to do, the volume scale factor to determine the linear. So, all I have to do is if I go 125, I have to cube root it, and I'll get my linear, which is equal to 125 to the power of 1 over 3. So, let's put that in my calculator. We go 125 to the power of, bracket, 1 divided by 3, bracket, and I get 5. Yeah, because this is cubed. This one's cubed. Linear is not. It's just centimeters. Okay? So, which is equal to 5. Now it says, show how to use the volume scale factor to determine the area scale factor. So first, I'm going to go cubed root of 125. I want to find the linear first, okay, which is equal to 5. And now, once I have my linear, because we cubed root volume scale factor to get linear, okay, then we must square my linear scale factor to get my surface area scale, or my area scale factor. Okay, so now I square this, that's going to give me 25. Or I could have done a shortcut and did 3 over 2. So I could have gone 125 to the bracket 2 divided by 3. And that would give me 25 as well. Okay, so 25 is my scale factor. That's how we do that. So hopefully you understood this and you have no problems. And as I see you tomorrow, we work on these questions together. Good luck. See you tomorrow.